So we've been doing these panels now for the last few years. And the topics we discuss are whatever you want to discuss. So you heard presentations this morning. It may have put something in your brain that you think we should talk about. You want the panel to end at 12:40, you said? So the panel's going to be short today, 35 minutes, but that's okay. None of us have any specific agenda other than to have good discussion on whatever subjects relating to computer systems that you want to talk about. And we're going to do this today, and we're going to do this tomorrow. Tomorrow will be longer, I guess, huh?
Tomorrow, sorry?
Tomorrow's panel will be longer.
Yes, tomorrow is 1 hour.
Yeah. And that's all I have to say to get started. My partner in this thing, Professor, the Brett Family Chair Professor of Computer Science and Engineering at the University of Michigan, Trevor Mudge. Do you have anything to add? No. Nothing, right? So what do you want to talk about today? Nobody wants to talk about anything.
Let's head to the beach.
You will go to the beach at the appointed hour, and there's no way to change that, so
Yes, there is.
we can cancel the panel today.
Just walk
Nobody
away.
has anything to talk about. Anybody?
How about the panelists?
I'm sorry?
How about the panelists? Do you have anything to talk about?
Maybe here a question from me. So,
Good.
very simple question, because I was at this conference last year from the GSA, so semiconductor organization, and there was one of the VCs there, the people who put money up into startups, and they said, everybody under 40, raise your hand. And I was quite shocked, because I'm not under 40, and almost nobody in the room there was under 40, and I thought, is this where the semiconductor industry is going? Is it really becoming commodity, much more a commodity, no new things and no new people? Are all the young people going to the software startups, to the, trying to
In
match
North
the
America,
Facebooks?
that's true, I think, but I don't think it's...
Yeah, so maybe we can do the same here and see, because I see quite some young faces. So who's under 40 in this room? So I think that's really great. That's very good for me personally. That's very good to see, because I was maybe slightly worried. Yeah.
Can I ask you just to talk about something? Why not the microthreads? Interesting to know what you think about microthreads and what the perspective for them.
What do we think about microthreads?
Yeah. The long thread.
They're very useful for validating what you already believe to start with. Because you can pick your microthreads very carefully so that they don't tell you reality, they only tell you that one little piece that maybe your product is good at. I remember a design, architecture of several years ago where the essential thing they optimized in that architecture was the ability to do procedure calls in one cycle. And so the guy who proposed that, who will remain unnamed right now, providing those procedure calls are not nested very deeply. And so what he did is he came up with a microthread called the Towers of Hanoi, which is a game that you may have played, where you know the game towers of Hanoi, we have 3 pegs, and the rings are all on one peg, and then you have to transfer them to another peg with the restriction that you can't put a larger ring on top of a smaller ring.
Right.
The code to do that did 0 computation. That's all it did was move rings via a procedure call. So the program was procedure call, procedure call, procedure call. But you gotta be sure that the number of rings on the peg is small enough that the degree of nesting is satisfied by the architecture. And so he did. And he got phenomenal performance benefit on that microthread. So, personally, I think microthreads are, so the Livermore loops were example of microthreads, right? But the
Are you talking about what is a micro benchmark? Micro benchmark? Yeah, what?
Yeah, well, so microthread, micro benchmark, I say the same thing.
What do you think?
And I say they have no value, so, yeah, what do you think? Or what do you guys think?
So it's like a kernel computation that does, is that a micro benchmark, or are you talking more about
I don't know if the
programming modeling?
micro benchmark. Actually, I asked to get more knowledge out of you. Essentially, it's creating subtasks for example, loop iterations, executing them concurrently. Perhaps you need to duplicate resources, CPU resources, for example. So I think you try to speculatively execute the next iteration of the loop while the currently is still running. I see it in a broader sense that you actually split the computation, whatever that is. You have a large window instruction, and you extract pieces of code and speculatively execute them. And if they fail, you roll back the memory. If the dependencies violate, so it's speculative parallelism extracted online by the hardware scheduler, let's say.
You a comment?
You want me to say something about it?
Only if you have something intelligent to add.
Oh, sorry, in that case.
You always, Keshav, how long
All
have I
right.
known you? You always have something intelligent to add.
Okay, so now that I understand what you mean by a microthread, we do actually use a similar notion in our system that does graph analytics and graph computations of various kinds. Okay? And the reason we need speculation is that for a lot of these graph computations, you don't know the dependencies at compile time, because which iterations depend on which other iterations depends both on the structure of the graph, which you don't really know at compile time because you're given some graph at runtime and you don't know what that is. And in addition, it also depends on runtime values. So if A is greater than B, then there is a dependence, and if A is less than B, there is no dependence, things like that. So basically all of the compile time dependence analysis ideas that the software community has proposed over the years simply don't work for these graph applications. Okay, so if you want to exploit parallelism, you do need some notion of speculation for most of these algorithms. Now, the place where we have found speculation to be useful is in computations where you can actually do the loops in any order at all. Okay, so these are not dual loops. Dual loops, you can do them in any order. However, there are no dependencies in dual loops. But in many graph computations, it turns out even if there are dependencies between different iterations, as long as it appears as though the iterations got done in some serial order, right, the algorithm is correct. And I can give you lots of examples of even single source shortest path algorithms like that. So what that says is when an iteration fails because some other iteration has grabbed some portion of the graph that it needs, it needs to be rolled back, but you don't need to roll back all the iterations that started before it. Okay, so we make a distinction between ordered loops and unordered loops, and I'll talk about this on Wednesday when I give my talk. So speculation works very well for unordered loops, where the iterations can actually be done in any order at all, as long as they appear to have been done transactionally. And for that, we found these micro-thread ideas to be invaluable. We don't do it in hardware, we actually do it completely in software. And we get very good performance. Although I'm sure if I talk to the hardware guys, we could probably boost the performance even further, but we haven't done it. But for the ordered loops where the iterations need to have been performed in some particular order, there we have found speculation doesn't work all that very well. And we use very different ideas for that. We actually build a dependence graph at runtime and then we update it to find what can be done in parallel without using speculation. It's probably far too much for a discussion, but we do use those ideas. They are useful for some purpose in the graph analytics.
So IBM, quite a number of years ago, had a project called microtasks.
Speak up, Trevor, they can't hear you back there.
I said it some years ago, IBM had a project to define architectures that could support what they called microtasks, which are your microthreads, as far as I understand from what you just said. And you might want to look at some of that. It's that what they proposed were they could stop and start instructions immediately in the instruction and restart them, so they're all restartable. And they had very fast synchronization in the hardware, so the thing could efficiently execute these kinds of small things. The overhead was very small, therefore you could split things up into small computation.
So when a dependency occurs at runtime, they freeze.
They can freeze.
They freeze the instruction, but
yes.
on the level
of an instruction, yeah. So they can stop it, and they had semaphores which were, guards or whatever you want to call them, in the hardware. They had a special memory which was that thing, so you could broadcast across all the processes. At that time, they could do it in a clock cycle. Today, when the layers become more sort of dominant feature, that may not be a model that carries over anymore. So this little tiny thing working here could stop that over on a separate processor within the instruction execution time. So they could run these things. That meant that they could make them, hence microtasks, they could make them small because the overhead. So their thought was they could get massive parallelism out of this. I don't know what came with it. It certainly didn't show up in any products.
But you need to be able to roll back also to avoid deadlocks.
Yeah. Well, that's right. They had there was a whole, series of IBM reports on the whole thing that sort of went into that whole architecture of how these things fit together and so forth.
So I'm not getting what's going on here. So what IBM did was design the hardware to be able to accommodate these things?
They specified the hardware, they didn't design it. I don't think it ever went anywhere, but there is a sequence of IBM technical reports.
But the idea was that they would come up with a micro benchmark and then specify what the hardware should look like. Huh? What?
They just specified how you could efficiently run small blocks of code and synchronize them with low overhead by saying what you need in the hardware is support for this. And then they sort of sketched out how you do it, but they didn't draw a logic diagram. And so it was...
The idea was eventually you'd end up with what, an ASIC for doing this?
No. You'd end up, it would operate on multiple CPUs, or multiple function units actually.
So it's like a coarser-grained data flow machine.
Yeah. But it was a conventional programming.
But is that what it is, what Keshav just said, a coarser grained data flow machine?
It sort of is.
I think that's the right mental
I mean,
model.
I'm sort of recalling this dimly from years ago, but
Which
you did it, I don't know. You do a search on microtasks, IBM.
And so they end up with what, 10,000 different?
Yes, exactly. That was the idea. You could, because you could break things up into such small units and efficiently stop and start them and restart them, and then you could have much, in principle.
And so programming then becomes, composing.
No. The programming model was the microtasks were created automatically from the
So
source.
the magic compiler
Yeah,
that
exactly.
defines.
No need to compile it, it should be done in the CPU,
Can't hear you.
the
That's the
scheduler extracted.
I'm sorry?
The hardware scheduler should extract them, those little pieces of code.
The hardware should extract.
Yeah.
We found that you need some amount of support from the programming model in order to exploit these kinds of ideas. So you can't just take any old Fortran program, for example, and expect to get good performance just because you can support fine-grained tasks.
Well,
And one reason for that is that you need to be able, what we have found for the applications we do, which is all these graph programs, you need to allow iterations to complete out of order. Right? Whereas if the semantics of your loop says that the iterations must appear to have been done in order, then it turns out there's a bottleneck there that we don't quite know how to solve. Guri had a student who just finished a PhD on some of these ideas, and we can ask if he's here, how that might work. Maybe he's ducked out. But, yeah.
If he was here, you'd be able to see his turban.
That's right. So there is an issue over there. If the iterations are supposed to complete in order, right, then there's a bottleneck, at least in conventional, if you implement that on conventional architectures in software. Whereas if you allow, the programming model says these iterations can complete in any order at all. However, each iteration needs to appear to have been done transactionally, then you're good. And we know how to build systems that scale up to about 512 cores, for example.
So what is the micro benchmark? The algorithm or the individual little
Why do you
peaks?
keep coming back to micro benchmarks? We're not talking about that.
So what are we
Yeah,
talking?
think
So
about it.
what are we talking?
Think more like multi-scalar.
Huh?
Think more like multi-scalar.
Multi-scalar.
Yeah, that's.
Is that what you, I don't believe
You might want to evaluate these things with micro benchmarks, but, or not, according to your view on those things.
No, but think
We're
about
talking
it.
about
So-
a computational model.
Basically speculative parallelization.
I'm sorry?
Thread level speculation, speculative parallelization. That's what, we're not talking about benchmarking at all.
No, Yale's question is about what kind of benchmarks can benefit from this execution model. It's graph computations, so things like, for example, take single source shortest path, or even breadth first numbering of nodes, right? Finding connected components in a graph, page rank computation. So those kinds of computations, because dependencies between different microtasks, or whatever you want to call them, different iterations really, right? Depend on the graph structure and on values in the graph. There is no way for a compiler to tell you this iteration is dependent, you can't build a dependence graph.
I'm having trouble making the jump between what Keshav is saying and what you said the IBM people were doing. I thought what the IBM people were doing, based on what you said, and I could have misinterpreted, is that they looked at tons of code
No.
and came up with these units of work that they would then specify hardware to handle.
They suggested that you could break programs into these small
Units of work.
Yes.
So they have an architecture that supports.
And then they went ahead and
No, is
specified,
that correct? They have an architecture, what's this?
they had a specification. It was, I wouldn't call it, certainly wasn't a drill down to the gate level thing. But what are the kinds of things you need to stick in these multiple function units?
Okay, so micro benchmark is the wrong model.
Yeah, it's a
But
different.
that's fine. So what I'm getting from Keshav is that you have an application you want to run on a computer. And now, at the programming level, you break that application down into units of work that you would then send to the hardware to do as units of work.
Well, the units of work for us are just iterations, so there's nothing
Yeah.
special about that.
I think
But
that's,
what we need to know is whether the iterations can complete out of order or whether they need to complete in program order. That, it seems like a very small point, but for us, that's a huge difference.
Yeah, you're talking about.
No, it is a huge difference, I buy
Weak
that.
parallel loops.
Sorry?
You're talking about weak parallel loops. So you have a loop, it is specified sequentially, but there is a chance, depending on the edges of the graph, that speculative parallel execution of the iteration would not fail the dependencies. And then you take a chance, and if it happens, you roll back. If you valid dependency. I'm talking doing this automatically in hardware.
Well, I mean, this is pretty automatic because you write, in fact, our programming model is just C++. And it's not any old C++, you have to use certain patterns that we give you. But it's C++ and our programs are legal C++ programs in the sense that you can feed it into a C++ compiler and execute it as long as you link to our library.
But each thing that's in this C++ program has to be from this set of patterns?
Where you exploit parallelism, it has to be from one of these patterns. The rest of it can do anything you want. The sequential parts of it, right? You can do anything you want. You know, there's nothing very different about it than saying, I give you, for example, Fortran, and then I let you say certain loops are do-all loops, right? And that's where I exploit parallelism. Now, the difference with these graph analytics applications is that there are no do-all loops in most algorithms. That's because there are these, see, typically what you're doing in these graph computations is you're updating the value of a node, looking at the values at the neighbors of the node. So if I have two nodes, let's call these active nodes, that's what we call them. So active nodes are places where you need to do computation. If you have two active nodes that are far away in the graph, you can do them in parallel, right? There's no problem. But if they're close by, right, then of course you have to be careful that you do them in one order or the other, but you can't do them concurrently.
let me go back to the earlier point of the over 40s. You didn't say what the VC concluded from this, or?
Well, the conclusion really was, let's not put VC money into anything semiconductor related.
Okay, because
And well, that's not
old
just
people
based
are
on the age.
untrustworthy, or what? Because old people are untrustworthy.
No, I think it's the other way around. There have not been many successful exits, and I think it's much easier to get started. You know, the barrier to entry in the software domain is much lower than the barrier to entry in semiconductors. And it's, you know, if you look at a 10 nanometer applications processor that's being designed now, just the amount of IP you need to procure, it's amazing that some of the Chinese companies can come from nowhere.
Yes, exactly.
Yes.
So in Asia, you can do it.
Yes.
Yeah, there's no such thing as IP in Asia. And they're not coming from nothing. But I'm wondering if it's because people over 40 are stuck in the rut and therefore not able to, what the VCs want to do is give you $1 and return $10 or $100 or $1,000. And you're not going to get that return from people who are stuck in a rut because they're just going to give you another 1% or 2%, which is not going to get this.
Yeah, they can only fool young people, is what you're saying.
I'm sorry?
They can only con young people. Actually, a lot of startups are not funded by VCs. A much larger number are not being funded by through conventional VCs for that the very reason that you said. I mean, they basically you get raped is the way it happens.
But I think
Would you say occasionally get raped
Yeah.
by a VC?
Yeah.
I would argue with the word occasionally.
Yeah. Well, you know, they dilute the thing. I mean, by the time you're into the third round of funding, you have nothing, there's none of the business left that you started. You know, so.
But the big question is, are there still, maybe that's a different question, but are there still opportunities where you can really introduce something new, unique, that presents a 10x value increase? I think the memory talk was very, very interesting, because I think this looks like an opportunity where people have not really looked at creative ways to make, you know, to get a step increase. But in processors, I have not seen things like that, or in SoC design. It's very, very gradual, evolutionary these days, I would say.
So there are still people coming out with crazy, what's that guy with the long white beard in the Bay Area?
The conveyor guy?
Yeah, the conveyor guy, exactly, yeah.
I called him Gandalf, he looks
Huh?
like Gandalf.
What?
I said I called him Gandalf, he looks like Gandalf.
But the conveyor belt idea is, you know, it's intriguing, right? Your point is well taken, that the barrier to entry in hardware is so much greater, you know. So any yo-yo who can write a program can all of a sudden, you know, is gonna solve all of those problems. And if he's under 40, he can speak with passion, and maybe con the VCs, maybe the conning is the other way around. Con the
The
VCs.
barrier to the entry, is it because of the manufacturing cost, or is it because of the engineering cost? I think tier 2, DAC, and there are the dollar equivalent that you think of the cable that said that take $50 million to make a socket, typical socket. And on the $50 million, I mean, $5 million goes for the manufacturing, the other $45 million goes for the engineering. And according to him, for example, it makes sense, is that unless we lower this $45 million down to $5 million, that would be $10 million, and then a lot more VC would be willing to fund it. But no one wants to invest $50 million, it would at easily end up like $70, $80 million. So you need to sort of lower the barrier 1 year to your youth. How do we lower the cost from 45 to 5? It's not just a question of-
Look, I mean, the cost is going up.
Why?
Because if you look at an IC, a silicon device these days, it's not silicon, it's like half the periodic table is in that thing. It's really, it's really difficult to manufacture. You have to expose the thing underwater, right? I mean, it's amazing anything gets built, actually.
And if you breathe on it, you'll get the rest of the periodic table.
Yeah. Speak for yourself, yeah. But it's been, look at Xiaomi, you know, the selfie in China. They built a SoC from scratch and got the second biggest handset manufacturer in China now, in like 3 years, 4 years or something. So I think their solution is the government gives them a loan, you know, gives them a loan, basically.
Are you sure it was from scratch?
Oh, yeah. No, I'm not sure.
But there's different ways, I think, to enter this market. IP is, so I work for a processor IP company. Certainly IP, you don't do the whole SoC, you don't make a mobile applications processor chip and say, you know, the market is 1 billion units a year and I'm going to capture 30%, but it's much smaller, but that's certainly much lower barrier to entry to do IP. You just work on 1 square millimeter of the whole design, but if you have something unique, you can license that and you can have a creative company and introduce new ideas.
Can you introduce yourself on, I don't know.
Sorry?
Can you introduce yourself? It's hard for me to read.
I work for Videantis, a company in Germany, in Hanover, that spun out of the University of Leibniz. And I've been in processor IP, so this is my 4th processor IP company that I work with, and always in the multimedia domain, so always focusing on video, image processing.
How many successful hardware IP companies are there?
Well, there's ARM, of course.
Yes, that's one.
Yes.
Maybe they're the exception that proves the rule that there are no successful.
Well, there's still imagination and synopsis. They
Yeah,
do all
that's
above
true.
100 million revenue and IP. Synopsis.
Well, are they really an IT company?
Their IP component is growing much faster
Is it?
than their EDA component.
That's the ARC thing that they call it, is that it?
Well, they have ARC, but they also acquired the Virage Logic, right, standard cells, memories, but they also do peripheral
But I
IP.
do some USB 3 and those. kind of-
Yes, a lot of, I call it peripheral IP, not just processors.
How many successful IP companies you said?
Yeah, I mean, in the hardware spec, how many people will give you a soft design of something?
Every one of these companies that are suing, the big companies,
Yeah,
their kind of maybe idea is a successful IP company, you know, in the hardware space?
no,
Huh?
I'm talking about, you give somebody a DSP thing that they can drop on their sock, or you give them a Bluetooth solution they can just stick in there. That's, so I imagine people that do Bluetooth, what's that one, I can't remember it now.
For Bluetooth, you mean?
Silicon radio, but is that?
Cambridge Silicon Radio?
Hmm?
Cambridge Silicon Radio?
Do I what?
They're talking about Cambridge Silicon
Yeah.
Radio? CSR?
I think they said it's successful.
Yes.
Recently acquired by Qualcomm 1 years ago.
Oh, right, well, okay.
Yeah, the one,
Maybe just the coincidence, also based in Cambridge, right?
yesterday, in fact, yesterday workshop, they did not speaker mention that Qualcomm acquired.
Yeah. Well, Qualcomm did have IP in the sense.
Luigi, I want to change a little bit the subject, if I may.
Good.
5 years ago, Trevor said that several papers on computer architecture were just revisions from papers published 20 years ago. You said that 5 years ago, so the question for everybody is, do you agree with Trevor? In the end, Trevor, do you sustain it?
I don't know. You know, they say the past is a different country, so
So I didn't
I
get,
may not be,
I didn't get the Brazilian accent.
I think, let me do a translation.
Please translate for me, Trevor.
Yeah, okay. I think what he's saying is, if you want to publish a paper, you just look at something that was done 20 years ago and rewrite it.
That's Trevor's claim.
Today-
And that was Trevor's claim 5 years
Because
ago.
nobody reads anything, they have no clue that they reinvented the wheel, basically, until they end up in a lawsuit, and then,
Trevor, that's why it's called research.
yeah, it's research, yeah. Yeah, it should just be search, shouldn't it? Yeah.
Yeah, so that's true, isn't it? First of all, that nobody reads the literature.
The scholarship level in our space is pretty, I think, pitiful.
No, so I thought you were gonna say pathetic, which was the word I would use.
Yeah, okay.
Yeah. So you made that claim.
I don't think people read what was done before. I can't believe math or physicists don't do that. I mean, they can't say, hey, guess what? I got this model of the atom. It's got like a nucleus and, you know, electron going around. Whatever, you know, it's like, you can't do. But that was, you know, that's a 100-year-old model, right? But everybody, but in our space,
Just to complete the question, that might happen because most of our experiments are not reproducible.
yeah, that's true.
So,
There's a lot of reasons for that. We don't publish negative results, I do.
right.
Right.
We also don't publish.
It's very hard to publish negative results.
All results in our space, it's the same graph, right? Like this, right?
So we also don't,
You can put anything on the axes you want, but it's gonna be, this is you, this is the other guy.
so we also don't publish where those results came from.
Right.
Should we?
Well, there are practical reasons why it's difficult, because the field moves so quickly. You can't, if you say, I'm gonna do this, and some guy wants to reproduce the experiment, by the time he's done it, it doesn't matter.
So he can't reproduce the
Why can't you
experiment
know stuff in the
because,
lab?
he can't reproduce the experiment because he doesn't have
All the
what you did in order to generate the numbers in the first place. So how about if you say, if you submit a paper then you must escrow, if you will, all the simulator, et cetera, that produce those numbers. And if the paper is accepted, and that all that stuff is available to the reviewers if they want to bother to check it. And if the paper is published, then all that stuff becomes
And then you end
available
up
to everybody.
answering email endlessly. Hey, I started your simulator and it's like, oh, down to this thing. You know what's wrong? It's like, no.
So the answer is, that's your job. Right.
So then you have 0 people. The other thing is you can't get funding to do that. You can't say, could I have, you know, a couple of $100,000 to reproduce the results of HPS, for instance.
So it turns out you don't need to get funding to reproduce the results of HPS, because Intel and other companies have already done that by building chips that reproduce the results of HPS.
Well, okay.
But as long as, my point is that as long as this goes on, that it's not possible to reproduce, because you don't have the wherewithal to even be able to reproduce.
Correct.
So, should we make it a requirement to, if you get a paper accepted, then you have to release everything that went into producing that paper? Seems a big danger of doing that, because now then the cost of entry becomes next to 0. So here my group has done a tremendous amount of work, and we built this thing, and here's the results. And then this yo-yo comes along and just takes all that, makes a little tweak, and generates papers. Is that fair?
No, but that's what Trevor is saying. That's why people can review things for 5 years.
I'm sorry?
That's why Trevor was making the claim. You can look around, change something in the past, nobody reason, go ahead.
We're not communicating.
That's not true, I think.
What's not true?
The fact that you can reshuffle ideas and no one will
Who knows? Why have you tried? And you got data points to support that.
But
I think there are plenty of
reviews
resistance.
and I think that reviewers they have sufficiently broad knowledge to hook on things and see if things are redone or it's the same idea or even resembles things. I think that the thing is not to be able to reproduce results, but the thing is that the papers, when we devise new architecture and new solutions, it's not exactly in a standard way or a standard frame that we can compare different architecture, this reconfiguration type, that reconfiguration type. There's simply too many
I don't think we're disagreeing with you, but the point is you've got to demonstrate one is better than the other for something. Otherwise, you throw it away, right?
I don't think so. We just need to show that the idea is new. It's not necessarily to compare it with someone else. It's just the framework that is not.
You have trouble publishing a paper in a lot of conferences if you just wrote about an idea.
Yeah.
You've got to do a graph that says, or a bar chart, my thing is better than the other guy's thing, based on some number, right?
Yeah, but then you got all these zoo of ideas, and we all actually not exactly select results, but we are not able to do a decent comparison because we shouldn't do it with another system which we cannot get or cannot produce. It's the concept of ideas in hardware architecture that needs to be somehow more condensed. So you are actually judging the new architecture, and you are able to compare it. It's an inherent problem of the field and the work that is done. You are never able to really compare. Not because you are not able to reproduce the result, or you are not able to do, because it's too wide, it's too loosely connected. You don't have that perspective framework to analyze architectures. That's the problem. I can come out with zillions of architectures in combination.
So I think
Guys, I'm really sorry, but we do have stringent tiny issues with the buses. We have to stop for today. Thank you all for coming, thank you all for speaking.